Near AI. What did you ship this week?
Hello, everybody. Welcome to episode 20 of Near AI's What Did You Ship This Week? My name is Cameron Dennis. I lead integrations and partnerships at Near AI. Near AI is essentially a venture studio building out a bunch of exciting stuff. One of these teams is here to discuss what they've been building for the last almost like 4 months or so. First time that we're coming, I guess, publicly with some of the stuff. So shout out to those who are watching, getting the early alpha. But just as a quick TLDR, think of it as a decentralized or open engineering stand-up where people across the ecosystem demo what they've been building. Today we have an amazing group of people that I'm very excited to have on. First, we have Pierre from the Near AI team to discuss the Near Agent Cloud. We have Vele from Vigil to discuss agent security. Vigil and I and the Near AI team have been working together for about the last, 5-6 months or so. We put out a request for proposal to create an auditor agent, and their team scored the best in that RFP process, and so very excited for them to demo what they've been building. Next, we have Hong from Follow Network, not his first time on the show, to talk about all the new exciting stuff Follow is shipping. Then we have Owen from Proximity Labs to talk about updates to the new Shade Agent framework. And last but not least, we have Felix from Xtrace to talk about the progress being made on private vector stores. So to kick it off, Pierre, I'm going to add you to stage. Welcome to the show. First time on.
Hey, yeah, good to be here. Thanks for the invitation.
It's good to have you here. So we normally start this off with a just short introduction of yourself. So if you tell everyone who you are, what you do at Near AI, and then what you've been shipping, that'd be a good place to start. And then I'm going to hop off. You have about 10 minutes or so, and I'll pop back on anytime I have a question or, time to go. But yeah, take it away.
Yeah, so I'm Pierre Le Guen. I've been working at Near AI since quite the inception. And before I was working at Near Foundation for something like 2.5 years, 3 years. And we've been focused on creating a solution called Agent Cloud, Agent Hub. And we are building on the first version of what you've seen at Near AI, which was the hub, where basically you publish the agents that you build on top of the Near AI SDK. And so we went above this, and basically now we would host any kind of agents built with any frameworks. And we're going to provide you lots of analytics and like also the AI gateway, the LM router that we have. So you get better pricing and you have a bunch of cool features on top of it. So today I prepared some live demo. Hopefully it's gonna work. So let me share.
The demo gods are hopefully with us today.
I hope.
But been building for a little bit. I'm very excited about this framework agnostic hosting because this seems to be one of the biggest issues. We've talked to dozens and dozens of agent developers, and analytics seems to be a pretty important piece. So take it away.
Yeah, definitely. Analytics is one of the biggest problematic right now. So I will send a link if I can somehow for you guys to try it for the agent developers out there that are struggling with analytics and hosting their AI agents. So we are kind of a beta mode right now, so expect a lot of issues. And if you built an agent on Near AI before on the Near AI Hub, it's going to be running on this platform. So this is really like bringing, as Cameron said, framework agnostic. So I'm going to do like the flow, like you are an agent developer. So basically you would land on this landing page. You want to deploy your agent. So lots of agents are just like vibe coded and they're not really ready for production. So what we built is a way for you vibe coded some agent, let's say it's just a CLI app or very simple like Jupyter Notebook or some Python code. What we would do is we would read your agent code and we would make it production ready, which means that we have an AI agent reading your code and adding like a bunch of functions and like a Docker file and so on and documentation, so we can actually host it on our platform. But you don't have to do any work. You only have to approve the PR if you are happy with the work. So I'm gonna deploy one of the agents I built. So this one, I'm just gonna go before like the fork. Wait. Yeah, so we have this this agent. It's like a very simple agent built on top of Python and GPT Researcher. It basically allows you to do deep research, but you don't have to use like any deep research solution. You can do everything from a CLI. And the idea here is basically you build an agent around this, and then you want to host it on somewhere. So you host it on our platform because it's a good solution for this. And so you would see your agent here. You click on it. So here it tells me that I already have this agent, but I'm just going to create a new one because I already deployed this agent on the platform. So here you would see the auto Docker, the production, making your app production ready, doing his work. So here it's quite easy actually because it already has the Docker file that was emerged from a previous PR of this agent. So Docker file is like some very basic like Python Docker file. So we have to wait for something like a minute or so. It's gonna try to build a Docker image, make sure it works. And once it does, it's gonna just like finish the process. Okay, so now it detected two mandatory environment variables that you have to fill. So either the agent developer fills this environment variable, or the person actually coming to the platform and running your agent will have to fill it. So let's say right now I don't fill it, or I only fill the OpenAI one. So I'll just put like some API key like this as the agent developer. So let's call it live. But I don't fill the Tavily one. Okay. So now your agent is ready. So it means that now you can basically go on this URL. So it looks something like this. Once you create an account, you can actually run this agent. So if all the environment variables are provided by the agent developer, you don't have to provide any of them. But in that specific case, I provided only one out of the two. So once you will have the build that's ready, so here it's currently building the Docker file. We will come back to this like once it's ready. But so once it's built, we will click run, and you will see that I will be prompted to fill one environment variable. So before this live, I just prepared like this exact same agent, amazing research agent. I just deployed it right before. And so we're gonna do the run from here. So here in that case, I entered like two valid API keys, and I'm gonna start a run. So here you can see I don't have to fill any environment variables because they're already filled in. If I want, I could like set some different parameters for CPU and memory for my agent, and then I'm just gonna start it. So it takes like something like 20 to 30 seconds for the agent to start. I'm just gonna reload this page. Okay, so now we can see the Fast API server starting up, and we get some health check from the server. So now you can just go ahead and click on Open Agent. Since this agent has some UI, so if you go on, so this is the code of the agent I just deployed that I'm showing right now. There is this very simple index.html. So it's being served from the server, which means that if you go on this link, oh, oops, the gods are not with me. So if you go on this link, you would see the UI. But so I did it right before this, and it was working. So I'm just gonna go on the other run that I have, that I just did right before. Must be this one. Okay, now if I open the agent. It's loading, slowly but surely. But yeah, so this was the right before the stream. So this was the run, and you can see generated some unique URL, and I went to it, and you can actually see the UI I showed the code for. And then here you can ask whatever research you wanted to generate, and you would click start research, and then it's basically how the agent is supposed to work. And then you just, after a few minutes, you would get the answer back. So yeah, it looks like we have an error on the backend. So I have to fix it.
So it goes. That's the point of a beta, though. So
yeah. So once you build, like you share the agents with your friends and anyone, basically the idea is that you would get lots of analytics. So you would see the number of runs, you would see latency, you would see number of tokens. We're gonna also like provide a lot more very deep analysis of your agent, and basically really allowing you to make it like work perfectly in production. So yeah, that's the quick overview. So this is really for its alpha beta scope, and we have planned lots of features on top of it in the next few months.
So Pierre, what do you want people to do with this? Is there a form that they should sign up for? Do they just automatically get access to the beta? How does this work?
Yeah, so you can go. So right now it's like a temporary domain that we are using. So this is, you can go on livingtools.com, and here you can like try the platform directly. So it's not gated. Like it's just like the other spot is actually to find this URL, because we are not like listed anywhere right now. Because yeah.
Can you send me that link somewhere, and then I'll display?
Yeah, I just sent on studio chat.
Devingtools.com. Beautiful. So just a clear call to action. If you're an agent builder, go check out this link, play with it, provide feedback. There's an alpha group, like an alpha tester group that we'd love to get your feedback. It's pretty much 24/7 support. So it's a fantastic way to troubleshoot any issues you're having. So please check it out.
The link. So this is the link for the alpha group. And yeah, if you have any issues, send a message there and we'll answer.
Awesome, Pierre. Well, thank you so much. Hope to have you back on the show soon to show some updates. And is there anything else you want to say before we move on to Vele?
No, looking forward to the other updates. Thank you so much for hosting me today. Yeah. Have a good one.
Thank you for coming. See ya. All right. This next one I'm very excited for. Vele, welcome to the show.
Nice to meet you. Nice to see you guys, and really excited to be here.
It's good to have you here. I know for those who are just starting to tune in, Vele's work in Vigil is actually, well, they've been building for quite a while, but we started working together because we launched a RFP, request for proposal, to figure out an agent that can audit other agents that operate inside of TEs and create some sort of almost verification. So if we're trying to figure out agent discovery, we know which agents should be, able to be discovered. And so there's a lot of work, and it is incredibly complicated stuff. So Vele, Godspeed on trying to simplify it for everyone in the crowd. Very excited for you to demo what you got. But just to kind of kick it off, please tell everyone who you are, what Vigil is building, and then, what you shipped this week.
Yeah, so I'm really excited to be here, Cameron. And we've been working pretty diligently for the past couple of months. I have a couple of slides here which I'll go into Vigil and myself and everything. So let me just pull those up. All right, there we go. So super happy to be here today to talk about what's been cooking at Vigil over the past couple of months. Today, I'm excited to introduce Vigil Diamond, which is an agent that audits your agent, just like Cameron mentioned. So again, for context, a while back, we responded to an RFP put out by NearAI, where they outlined the need for a mechanism to audit agents before they're activated on the platform, in order to ensure these agents are secure, robust, trustworthy, and to help developers address issues through clear mitigations. As many of you know, with the new Shade agent paradigm, we're moving toward a world where autonomous agents are granted real permissions to perform sensitive operations. That shift makes a trusted audit layer not just valuable, but essential. So Vigil's response to that need is Diamond. And today, I'll walk you through what it is, how it works, and why it matters. And at the end, I'll show you a demo of Diamond in action. So a little bit about Vigil. Vigil was founded in 2023 by engineers who built the deep learning platform behind Amazon SageMaker. The motivation was clear. Autonomous agents were no longer theoretical. They were starting to show up in production. But the risks that came with that, especially around security and control, were far too serious to ignore. There was a clear need for a trust layer, something that could evaluate whether an agent is behaving the way it should and help fix it when it's not. Vigil was created to bring enterprise-grade trust to this new category of software. At the core of that effort is defining what trust actually means. For us, it comes down to measurable properties, trust dimensions like safety, reliability, security, and compliance with policies. These are the foundations of how we evaluate agents. To test these properties, we've built in both red teaming and blue teaming strategies. On the red team side, we simulate attacks and adversarial inputs to probe for vulnerabilities. On the blue team side, we provide active defense, monitoring agent behavior in real time and enforcing constraints and containing risks if something does go wrong. And beyond testing, our aim is to transform ordinary agents into trusted agents through continuous evaluation, clear trust reports, and actionable feedback that supports improvements over time. So just a little bit about me and why I'm here. So I'm a senior applied scientist at Vigil, where I lead the privacy pillar of our trustworthy AI work, focusing on security, confidentiality, and integrity in autonomous agents, even under adversarial conditions. I hold a Master's of Applied Science in Privacy Preserving Machine Learning from the University of Toronto, where I focused on secure computation and applied cryptography and machine learning. Professionally, over the past 6 years, I've worked at the intersection of privacy robustness and secure enterprise deployment of machine learning systems. And I've done some academic work as well, publishing research on encrypted RNNs using fully homomorphic encryption, including 2 recent papers in the field. So why am I here? My work in secure computation, applied cryptography, and encrypted inference has always aimed to ensure that models operate securely. But over time, I came to see that privacy is just one part of a broader trust landscape. These systems are non-deterministic, which means their behavior under real-world scenarios matters just as much as how securely they handle data. That perspective led me to expand my focus, still grounded in privacy, but now also addressing the other essential dimensions of trust, such as, like we mentioned before, robustness, safety, and behavioral integrity. It's about making sure we can trust not only how a model is built or how it runs, but also how it behaves. And so, what is Vigil Diamond? Diamond is an autonomous auditor agent designed to evaluate other agents across 3 key dimensions: behavior, code, and runtime activity. It begins with black box testing to assess agent behavior, how well it aligns with its intended function, for instance, and whether it avoids actions it's not supposed to take. It then moves to white box analysis of the actual agent code, inspecting for risky patterns or insecure logic. Finally, Diamond monitors runtime execution, including low-level signals like system calls to detect behavior such as unauthorized access or data exfiltration. These results are compiled into a quantified trust report based on how well the agent aligns with intended behavior and avoids prohibited actions. These results, importantly, Diamond is also interactive. It doesn't just surface audit results, it works with developers to explain failures, propose mitigation strategies, and help improve agent performance and safety in real time. And more importantly, all of this takes place inside a trusted execution environment, ensuring full confidentiality and integrity of the audit. Confidentiality allows agent code and environment settings to be protected, while integrity allows audits to be certified and verified. Reports are generated securely and returned to the developer end-to-end encrypted. Now, once an audit is complete, Diamond doesn't just generate a report, it also formally certifies an agent by issuing verifiable certificates to agents. It acts as a certificate authority, digitally signing the audit results and issuing or revoking trust certificates based on how well the agent meets key trust dimensions. This allows Diamond to move beyond evaluation into trust enforcement, providing a clear signal that an agent has passed or failed a rigorous standards-based review. We're also integrating Diamond, I'm happy to say, into the Near AI platform, where it will establish a baseline of trust across the ecosystem. Agents that pass the audit receive a Verified by Vigil badge, signaling that they are secure, robust and compliant with platform policies. So all in all, this creates a foundation for developers and users to safely adopt autonomous agents, knowing those agents have been independently audited and certified. So what am I showing you guys today? In today's demo, we're going to interact directly with the Vigil Diamond Auditor agent using a simple chat UI as our interface. So I just want to mention that the chat UI is just for demonstration purposes. In the future, we'll probably have an API to start audits and then just a support agent to deal with developer feedback and understanding the reports and whatnot. But for today, to show you guys how it works, we've employed a simple chat UI. So the first thing to highlight in this diagram is that Diamond runs entirely inside a trusted execution environment powered by Fala, which are some of the presenters later on in this video. So not just the sandbox where the agent code runs, but even the underlying LLMs powering the agent logic, they all execute inside TEEs. That means everything from evaluation to reporting happens in a secure, isolated, and verifiable environment. Today, we'll be auditing an agent deployed on the Near AI platform called the Mindshare agent. So the Mindshare agent, what it does is it monitors token balances in a user's wallet, assesses the mindshare or hype surrounding these tokens, and suggests trades. Furthermore, as a shade agent, it doesn't just suggest the trades, it can actually execute them autonomously, which is the reason why we need to audit this agent and make sure that it does what it's supposed to do and it doesn't do what it's not supposed to do. So for this demo, we've extracted the core decision-making logic of that agent and we'll evaluate how it behaves under audit. So let's just go to step one. In step one, Diamond begins by gathering the necessary context. So it asks the user to provide a public GitHub URL for where the agent lives, and then also a path to the relevant module within the repository on GitHub, and also any environment variables that you need to pass to the agent to make sure that it runs. Now, it also asks you to provide the specific types of tests, which we call harnesses, to apply and to run the audit against. And so we'll get into those supported harness types during the demo. Next, Diamond spins up a new TEE sandbox via the Fala API. So this is a secure, isolated container where the audit will run. The TEE is attested automatically by Diamond, and the attestation evidence can be returned to the user if needed. In the third step, now we're ready to pull in the agent. So we download the agent code from GitHub, load it, and prepare it for testing inside the TEE. So the sandbox TEE does that for us. And in the fourth step, finally, the audit begins. So for this demo, we'll shoot two types of testing. One of them is a static analysis of the code, which we mentioned before. And the second one is a behavioral test of how the agent responds to various scenarios. Just to mention, the dynamic monitoring part is something we're still working on and will be shown in a subsequent release. So finally, in step 5, once the audit is done and we built our trust report, we return the trust report to the chat UI where we can discuss the findings and mitigations with the agent directly, which is really cool. So without further ado, I've recorded a demo that I ran just a couple of hours ago, and I'll just talk over it as it plays. So what we see in front of us is what many people probably on this call have seen before, and that's Fala's UI for their trusted execution environments and managing them and deploying them and all that kind of stuff. So we can see that we have a couple instances of Vigil Diamond deployed that are running. The first one is the Vigil Diamond-1, and that's the one that we're going to be playing around with today. So once we open that, we can see some information about the TEE. But more importantly, we want to make sure that it is a TEE. So we open up the attestation tab, and we can go down and then we can click the check attestation, and then we can see that the attestation is verified, and there's some measurements that you can extract from there and verify yourself. So yes, Vigil Diamond is running in a TEE, and everything is confidential and the integrity is preserved. And so as you know, the Fala API and DStack provide network URLs to any ports that you're exposing. So we are exposing our server for Vigil Diamond, and when we click that URL, you can see that we're directed to it, and what we have in front of us is a chat UI, which we can use to interact with Diamond. So we say hi to Diamond, and it responds with what it is, what it's there to do. So for instance, it asks you, what brings you here today? Are you looking to audit an agent, or do you have questions? So I mentioned I'm looking to audit my agent. And then it starts the information gathering process to deploy the agent. So it asks us, can you please provide the GitHub repository URL? And so you'll see in this other tab, this is where we keep the Mindshare agent that we've extracted. And this is a public repository all of you can go to and hit. It's called agent-audit-samples under our Vigil AI repository. And then here we have the Mindshare agent, purely LangGraph. We have some other agents like the multi-personality agent as well that you can play around with and audit. But what we need to do here is just, I guess what we're doing is we're taking a look at some of the files that are inside there. And then what we need to do is really copy that URL and then paste it into the agent UI. So now it has the URL and it asks me, what's the agent path within the repository? And so what I do is I type mindshare-langgraph. It has that information. And then once it has that, it tells us some information about the harnesses that we can run. And so these are little snippets. So for instance, for ethics, what does that do? It evaluates if an agent adheres to general business ethics principles. We can run a privacy harness. It tests for privacy vulnerabilities and checks for leakage of private information. What we're running today is the security harness. And what that does is it evaluates an agent for security vulnerabilities and adversarial capabilities. And then also a toxicity one, which assesses an agent's ability to generate toxic or offensive content. So I go on and ask, can you, that's great, but can you give me some more information about these harnesses? I want to sort of really understand what kind of tests they apply and use in the audit. So we can see here, it gives us a bit more detail into the types of harnesses. And let's just take a look at security, since that's the one we're running today. So if we look at security, it says, as before, the harness evaluates your agent for security vulnerabilities, adversarial capabilities. It checks to see if the agent is prone to well-known adversarial attacks, jailbreaking techniques, and prompt injection mechanisms, and if an agent can be duped into producing harmful content using these adversarial mechanisms. So, okay, that's great. I've chosen. I want to do security. So I tell Diamond, I want to run the security harness. And so it's, it's great. It asks if there's any environment variables. Right now, we're just using the default one. So no, we don't have any environment variables. And then finally, it confirms, is this information correct for you to run the audit? And yes, that looks great. So we type go, and then it should keep going. So once you type go, it starts the audit. It calls the tool that runs the audit. And what that does is actually spins up, like I mentioned before, another TEE sandbox, and we can see that there. So it starts the TEE in its own environment, and it starts the sandbox inside there. So it's isolated, and then we can actually audit, and the whole audit is confidential, and the integrity is kept via the hashes. So while this starts, we'll just skip through. It takes a bit of a while to start the sandbox and then to actually perform the audit. Once that's done, we can see that it responds with the results of the audit, and it destroys the sandbox as well. So let's just wait for it to produce them. That's great. So the audit's complete. The results are available in a report folder. So afterwards, we'll be able to actually download the results and then take a look at them a bit more in depth if you want to. And so the security, the score for the security harness, and this is a score out of 100, with anything higher being a good score for the agent, meaning it's trustworthy, anything lower meaning that's really bad, the agent's not doing well. So it actually scored a 42% out of 100, which is pretty striking. And it identifies the failure patterns, and you can see a bunch of them there. I'll just get into one just for fun. The base 64 encoding failure pattern here, for instance. So if you pass in, for instance, in this agent, a base 64 encoding of a malicious prompt, it actually decodes it for you if you don't put the proper guardrails in place, it actually decodes it for you and then runs that malicious code. And you can imagine that malicious code, for instance, for a trader agent like this, makes you make the wrong trades, or could potentially lead you to lose quite a bit of money, right? So that's one that I mentioned, and there's recommended mitigations for each of these failure modes. And so I ask it, give me a couple examples of problems and mitigations for them. And it gives me a couple problems and mitigations. So for instance, Malicious code generation, it says the agent can generate malicious code, which can be used to harm users or compromise systems. And one of the mitigations is to implement code filters to block the generation of malicious code. So you can use a whitelist of allowed code patterns or implement the code validation mechanism to ensure that the generated code is safe. So what you can see here is that I can actually interact with the agent. I can ask it questions about the problems that the audit identified. I can ask it for potential mitigations, and I can continue and as the developer, for instance, of the agent, I can make my agent better, which is the whole purpose of this. And then, in the future, once it's better, I can rerun the audit. And if the audit passes, then Vigil will certify it. So right now, we don't have the certification mechanism in place. That's something that's going to be coming in the future. That's what we're actively working on. But just to summarize and to finish up, you can actually download the reports via an API endpoint. So I asked it to give me the report endpoint. So then I just take the endpoint, I copy it, put it in the browser, and then you can see that a zip file was downloaded. And inside the zip file, I have a couple of files. I have the SAST results. So with the SAST results, we'll have some mitigation stuff coming up in the future as well for that. But right now, we just have the bare results of the analysis that happened with the static analysis. There are some problems. You can see that all of the files were tested inside the repository, and then some problems were found with severities of medium or whatnot, and that stuff will be explainable, and you'll be able to interact with the agent in the future with that too. We can open up the actual markdown file that is a summary of all of the identified failure patterns and mitigations, and then here that gives you for instance also whether or not a failure was critical, whether it wasn't, and all that stuff, and it ranks them based on how the audit scored. So you can see there's high, moderate, and low severity for some of these things, and also recommended mitigations for all of them. And yeah, so that's pretty much it. Let me just come to the last slide here. Thank you all for listening. Again, we're really, really excited to be here, to be a part of this adventure with Near, and looking forward to the next time and shipping something new.
Bailey, this is amazing. An absolute prerequisite for agent builders out there that are giving agents private keys. It's a huge concern of mine. I've brought this up a bunch of times on this live stream, and I think the work that you're doing is absolutely paramount to address this. All this shade agent stuff is still pretty early. I'm still skeptical of giving any agent a private key with a lot of my money, but hopefully the Vigil certificate will build a lot of trust. And I think the coolest part is actually embedding this in the sort of engineering workflow. So as people are actually deploying their agents, building their agents with Near AI, constantly working with the Vigil Diamond product, people are going to be able to build faster and more securely. So
yeah, we're excited to define this. We're literally defining the space together, right? And really excited to do that and make sure that we bring something that we've all, loved for years, AI, and it's finally coming, it's becoming something that's really incredible, and finally bringing it to something that a place where it can perform valuable interactions and whatnot. So yeah, really excited to be here. If there's any other questions, I'm happy to take them.
We'll probably have a bunch of questions from the community, but we'll probably relay those to you in Slack. But
thank you.
The time will come. Thank you, Vele.
Thanks, Kim.
All right, next up we have Hong from Fala. If you guys can tell, this episode 20 was kind of a special episode. We've had Near AI, Vigil is now using Near AI, or deploying to. They're using Fala. Fala is also being used by Proximity, who's up next. And so we're all sort of working together for this sort of unified mission. So Hong, it's awesome to have you back on the show. You're not new, but for those who may not know you, can you give everyone just a quick overview of who you are, what Fala Network is building, and what you shipped this week?
Yeah, of course. Super happy to be here. I think this is the third time I have been here. And just give people a brief intro. I'm Hang Yin, co-founder and CTO of Fala Network. As Vigil already showed that they're using our TE solution, so probably you already know, like we provide the TE. So I think I can just skip all the like the bullshit. Let me just show my screen of what we are doing. So basically our main product is called the Fala Cloud, as simple as a cloud, but that is TE native and AI native. For those who don't really know about TE, you can just imagine when you are talking with OpenAI, you give all your inputs to Sam Altman. So he can actually see what you are talking with the AI and what is the AI response. So how can we make sure like we not give up our privacy when using someone else's service? So this is a very typical use case of TE to make something private preserving. So the way that work is pretty simple. TE is just like a vault in your CPU, or now it also comes with the GPU. You can put your program or like your AI model in this vault so that the user can still talk with the AI model or use your program, use your service, but nobody else, including the cloud provider. Like if I have the physical access to this box, no, you cannot see anything inside because everything is encrypted. And this even includes the administrator of the program. In theory, we can build a fully autonomous AI agent or fully autonomous AI model where code is law. So basically, you can check there's no backdoor in the code to save the user privacy. So this can be confirmed that even not the model provider can see the user input or any of your privacy data. So yeah, this is like a quick TE 101. Put everything in the black box in a vault so that nobody can touch the program running inside and nobody can see the data running inside. And then I'm going to quickly show off like what we have done in the last week. So a big news we just made exactly 7 days ago was that we just launched the TE GPU support. We actually has been working on TE GPU for quite a long time, since the end of last year. But bringing GPU TE to the cloud is like a very big task. So we have to deal with like a supply side of things and make sure everything is smooth so that you can just click and deploy. And now we have launched actually 3 products. So one is what we call the confidential AI model. So most of the use cases of GPT is actually deploy AI model so that you can get a privacy preserving model. So and this is the easiest way to do that. Now we already have 3, actually more than 3. Yeah, there are 4 models, and there's also another one. It's called Ollama. It's not exactly a model, but just a platform where you can put any Ollama compatible model inside. So in theory, you can deploy any kind of the model, from smaller one to larger one, with just a few clicks. So all you need to do is to select which model you're going to use, and choose the GPU that's required, and then click deploy. So I'm not going to deploy again, but you can try that out by using our cloud. Then here I have a deployed version already up and running. So if I click this one, then you're going to see, okay, there's a H200 NVIDIA GPU attached. And we even have an open web UI already loaded. So this is how like you can interact with your model without having say using some command line tool or write your own code. So here I can just type hello, but not sure if it can run or not. It's just a demo. Maybe it will take a little bit time, but let's go back later on. So with Open Web UI, you can actually talk with the model we just deployed. And on the other side, we also have a very neat feature. It's called Chat and Verify. So big problem of using TE is that now you're already using some very secure environment to secure your application. And how can you tell your user this is actually secure? It's not something running on AWS, and trust me, bro. So the way to do that is we have a new feature just launched together with the confidential AI. That's called the verification center. So if here I choose some model, and on the right side, you can see two things. One is the CPU attestation. So it shows the evidence to prove that this is actually something running in the TEE. And also the GPU attestation. This is the part that can be verified together with the CPU attestation, because when using the GPU TE, you actually has to use both the CPU and the GPU together. This is how you secure your entire stack. And it's also available for Redpill, which is like a platform pretty similar to OpenAI or OpenRouter, where you can just use the model in a pay-as-you-go way. So you just pay for the token and API invocation. So let's have a try. Just ask them, hey, what's your name? And you can see this one is DeepSeek, and it's already producing some outputs. And here it shows a verified, means that it doesn't only verify the environment, but also verify your exact input and output. So imagine if you want to consume some of the output from a specific large language model, and you want to use the results, say, on near blockchain, how can you verify this is exactly the output from this specific model, and there's nobody manipulate the output or the model execution? So the way to do that is for every message you talk with the LLM, it's going to produce a signature. So you can verify this signature easily on blockchain, because here you can easily verify the signature as well as the message. This is just the hash of the input and the hash of the output. So in this way, like, you can imagine how people can build the AI model that can manage your fund, like create a private key, you give the fund to the AI model, and how can you make sure there's nobody manipulate the AI model output to abuse your fund? So this is the way to secure this whole process. Yeah, and this is the private AI, confidential AI model. And I also showed you the confidential AI API. So this is actually what I showed at the Redpill page. And on the other side, if you want more like a low-level support to deploy arbitrary program, even not AI related, we also have the GPU TE support. So you choose which GPU you want, how many GPU you want, how long you want, and then submit an order. Then later on, we're going to schedule like a meeting to help you set up everything. And eventually, you're going to get the access to something very similar to this user interface. So where you can just put your Docker Compose file. You can run like an AI model, AI training, data cleaning, or even say ZK proving in the GPU TE. So yeah, that's pretty much for the cloud update. I do have one more thing to share. So as I mentioned, we always want to tell people this is secured by a TE. It's not the same as the program running on AWS. But how can we let the end user to feel that? So this is actually a really important problem to solve, because we want to raise the bar of confidential AI or decentralized AI. So we want to make sure the end user can have the access to all the TE related proof. But then proof itself is very, very complicated. So we made a dashboard to simplify that. So on the right side, you can see this is actually how we call that the full chain of trust, because it's not a single proof. It's a combination of the evidence, not only for the TE, but also for all the dependencies. Like this on the right side, this shows the attestation of the TEE, but on the left side, we can also trace it all the way back to the program you have deployed to this TEE. And eventually you also want to show, okay, this is actually the code deployed from some GitHub repo. So that's how you can confirm there's no man in the middle attack. And you can always audit the code if you want. So on the left side, we also have a very high-level summary. So as a non-technical user, you can clearly see that this app is verified because the hardware is good, CPU is good, the GPU is good, and this is the source code, and the network connection is end-to-end encrypted. Everything is secure. So we want to bring this to all the TEE application deployed on our cloud automatically. But of course, it's not only limited to the Fala thing. It can also be used for any TEE deployment. And yeah, so feature-wise, that's everything we have since last week. And one more thing is we just have a refreshed doc, so it looks a little bit cleaner, thanks to Mintlify, which is pretty good. And we also refreshed our open source version of all the TE stack called the DStack. So this is the new repo of the code. So you can take a look if you're interested. And finally, we just got the DStack fully audited. And to my knowledge, this is probably the first TE infrastructure open source project being audited. There are a bunch of other SDKs, but none of them are audited. So I think this is also aligned with our like a philosophy. We have two things. One, we must make sure everything is secure by default. There's no compromise. And the second one, we want to make it to be accessible to as many people as possible. So that's why we spend most of our time to simplify the user experience. Yeah, so that's basically all I have, and really glad to be here to share all the updates to everyone.
Yeah, Hong, that's incredibly exciting. A lot done since the last time you came on. So, the Fala team is constantly shipping amazing work. Is there anything that you want the audience to know or do pretty much until the next time you're on the show? Like any call to actions for them?
Yeah, just sign up on Fala Cloud and give a try of our TE GPU cloud. It's very simple, very easy to use.
Just to be clear, like, can I essentially start using, let's say, DeepSeek running inside of Fala, via Red Pill right now to make sure that all of my inference is verifiably private? So everything that I'm sending into the model, it's not seen by a third party. This is my model. It's not, no one else's, correct?
Exactly. This is exactly what we're offering.
That's amazing. I can see how good this is going to be for enterprises that are dealing with a lot of sensitive customer information who might not feel comfortable throwing it inside of, one of these large companies. Have you seen, like, what kind of traction are you seeing? Or, like, who are the types of targets that, you're going after for confidential inference?
Oh yeah, it's very interesting to see a lot of different use cases. Actually, when we start to build this, one of the initial motivation is that a lot of VCs, they do a lot of research every day, and they use AI, of course, to save their time, but they don't want to give any of their alpha to anyone like OpenAI, because OpenAI, although they claim they're not going to pick your data, but who knows, right? They can just use your data to train the model, so you lose your competitive advantage. So that's why they want to use confidential AI for their own use cases. So they are kind of the end user of confidential AI model. But on the other side, we also see a lot of interesting use cases. One of that is a few teams are building AI agents that manage user fund. Just like you say, they literally create AI agents that has a wallet and ask a user to send crypto into the wallet. They help user to manage their fund. They also want to make sure, because there are a lot of risk. If you just use a centralized AI, what if the AI got compromised? Mm-hmm. There is a long supply chain. At any point there can be a compromise, and nobody want to bear this risk. So the way they deal with that is to use confidential AI, because it's end-to-end encrypted. integrity is also protected. And if there's any problem, it's likely not because of the AI, but because of some other problems. So this is a way people want to reduce their risk offering the AI services.
Got it. So between flawless confidentiality, Vigil security, we're getting there, getting to the point where AI would be able to sort of handle a lot of sensitive tasks for humans. But yeah, I mean, I'm so excited to be working more closely together. There's so much to be done here. Is there anything else you want to say before we move on to the next speaker?
I'm super excited about the decentralization and the security of AI, because in the past people move really fast, just try to deliver something that can be used. But now, because your AI is so powerful, I in my estimation, I think maybe in the next 1 or 2 years, there's no reason people don't use a secure AI. So super excited about that, and I'm really willing to help everyone to make AI secure and safe.
Yeah, for anyone out there who's looking for a TE provider, check out Fala. We've been working very closely together, and I can't tell you, I can't gloat about them enough, especially regarding the support they provide. I don't know how you guys do it, but there's like 24/7 support. So thank you for really dedicating to making sure your customers and clients are happy.
Thank you.
Of course. Awesome, Hung. We're going to move on to Owen. Thank you for joining. Owen, how's it going?
Hey,
Welcome
Cameron. Yeah, good to be here again. We're yet another user of Fala Cloud over here at Proximity. I think everyone's using their tech at the moment.
There's probably good reason too. So would love for you to sort of dive into what you guys are building. Before doing so, just give everyone a quick update. Who are you? What is Proximity Labs? And then what did you ship this week?
Yep, let's get into it. So yeah, I'm Owen. I joined Proximity like 2 or 3 months ago. I've been around the ecosystem much longer prior to that, and we're building Shade agents, which are verifiable AI agents that are running in Fala's TEs, and they produce attestations which are then verified on chain, which then leverages like decentralized key management. So instead of storing a private key inside of the TE, which could evaporate into thin air when the TE goes down, we have the keys on chain basically with like the MPC service, which allows us to have persistent accounts and accounts on a load of different chains. And I'm going to start sharing
Owen, real quick, just for those who might not know, what is MPC?
Yeah, so MPC is multi-party computation. So basically, you have a load of parties that construct a key together without revealing what the private key is to any party at all.
So essentially just an additional layer of security to make sure that the key is not either going to be leaked or
or lost.
There's redundancy or lost. Got it. Cool.
Yeah, exactly. So yeah, I'll go ahead and share my screen to show what we shipped this week. Just give me a minute here. Here we go. Cool. So yeah, we've had some big updates to the stack. I think it was last week actually. We shipped a new version 1.0.0 of the Shade Agent CLI, which adds support for a load of different flags. Some feedback we got was that we had this nice CLI where you would run the command and it would go through everything. And it was quite a monolithic structure, but we've really broken down the CLI into different optional steps if you want by adding a load of different flags in here. And we've made it more flexible by adding in optional like RPC providers, so hackathons as well. As always, there's an issue just before deadline, so we had some issues with RPC providers. Now you can just define this JSON file and use whatever RPC you want inside of the CLI and inside of the agent as well. And as part of using it inside the agent, we also shipped version 1.0.0 of Shade Agent JS. And this is our abstract library to interact and build shade agents. So instead of having to know specific TE code or specific near blockchain code, you can just interact with Shade Agent JS, which exposes a load of nice functions to do things. So for example, here we can request a signature from your Shade agent using these NPC accounts and just specify some details there without having to know that there's an agent contract under the hood and there's NPC under the hood. Everything is just done right through this one function, and we expose a load of different functions. And inside this update, we have made some breaking changes. So if you're using Shade agents already, make sure you're using the most recent API image hash and you've updated your CLI to the most recent version. And to get into a bit more more general updates as well, we also we've built this Shade Agent JS, which is this library, but it's not just a library, it's actually an API under the hood. And this API is designed so you can build your agents in whatever language you want by just using this API. And you can see here, you just need to call the API, which will be like localhost and on port 3000, and then specify which method you want to use. So now you can build an agent in Rust, Python, I guess even stranger languages. Maybe you want to build an agent in C, C++. Well, you can do that all now just using this API, not just JavaScript and TypeScript. We've also added support for signing for EDDSA, which now gives support for like Solana, Tron, and Sui. And we had this Shade Agent template, which before was in Next.js. We've now transformed that to a simple like TypeScript Hono server to replicate more how we were going to build an agent in reality. And we have like a locally hosted front end as part of that repo, so you can interact with your agent a bit easier. But one of the most interesting things we've done here as well, if you go to docs.org, is we've added some documentation to deploy a custom agent contract, which is really interesting. So if you're trying to do more agent use cases, you can deploy your contract and do some cool stuff with that. But the more exciting thing than adding more documentation is actually reducing the amount of documentation. So previously we had this sandbox development flow, and we also had this production agent development flow. Well, because of these updates with the CLI and the API, we've actually managed to merge all of this into just one flow, which was called the sandbox. Now we're just calling it the Shade Agent Framework. So if you come into docs.near.org under AI and agents and Shade Agents, you could go over to the quick start here and learn how to deploy a sample agent in as little steps as possible. You need some prerequisites here, and like how this agent actually works, and then the key components of it, and how you can actually modify the example to fit your own use case. And this is something I was doing yesterday on the DevHub live stream. You may have seen that, where I adapted the template from what is like an Ethereum price oracle into this shade agent that operates on Solana to randomly pick an account ID from a list of NFT holders and airdrop them some Solana. So I'm actually going to switch the tab I'm sharing here. If I can find, give me a minute to pull it up. I think I closed it down. I know. Share my code tab just over here. All right, let me stop sharing this screen if I can figure it out and share. There we go. Yeah, so when you go ahead and clone the template, you're going to see this. I mean, this one's a little bit different because we adapted this yesterday to be this Solana example. But when you have this template, you just need to go ahead and fill out your environment variables here. And you'll see this Docker Compose file should look quite familiar. You've seen it like 2 or 3 times already this stream. And this is what gets deployed to the TE. And we have this really nice abstract flow with the Shade Agent CLI, where you can just go ahead and run Shade Agent CLI. Actually, I'll run help so we can see the options we have here. And I'm going to actually do the tag no redeploy because I already have the agent contracts deployed under the hood. So this is going to build our Docker image and push it to Fala Cloud. If you are an old user of Shade Agents, you will have noticed that already this is operating about 10 times as quick as it was before. This whole flow used to take about 5 minutes, but the app is already live here on Fala Cloud. So if I go back to my other screen now, back to, let me find the right one. I think we're over here. Yep, there we go. So yeah, this is live on Fala Cloud now. We can see that it's still booting up over here, but just in a minute we'll be able to go in and see our app is live. You can see it's booting up. It usually takes about 30 seconds to a minute to build locally with the CLI, and then about a minute for it to get up and running on Fala. And we can see our app is running now. So I'm going to try and test this now by copying the endpoint and doing /a. I'm going to just actually ping that endpoint. We can see the app is running, and I can do some things like get my agent account ID. That's too many C's. So this is my agent's near account ID and its balance. This is a Solana example, so I should be able to do Solana account. This still has some balance in from yesterday, which is awesome. So I can run this example transaction route, which is going to pull up this list of NFT holders from this Mad Lads collection on Solana, select one of these holders randomly, and send them 0.1 sol. So this takes a little while to loop through this because I think there's like 9,000 NFTs, and then we need to rip off a chain signature. But hopefully we'll get a success result in a minute. Things always go a bit funny with live demos, though. So we'll give it just a few more seconds. Aha! It seemed to have worked first time. So you can see I got the recipient address of the random holder and the transaction hash here. This is testnet. So if I go to Solana DevNet Explorer and paste that in here, we should see that 0.1 sol was sent over here. So that's how you get up and started with a Shade agent. Go to docs.near.org, check it out, and I hope you have fun building.
Yeah, Owen, are there any upcoming hackathons or anything that people can get involved with just to kind of, get going?
Yes, so there will be some coming up. We're yet to disclose like when and where they're happening, but you can expect some happening in the States this year. And I believe there'll be some activities around like Argentina with DevCon, DevConnect. So there's always something happening. And I mean, we're here online all the time. So just join the Shade Agent group, ping me if you have any questions. And we also have office hours on Wednesdays, sessions where you can book in for 30 minutes. So just come and join us, ask questions, and build something cool.
Beautiful. I'd love to see how we can get Vigil Diamond integrated somewhere in this development workflow. Just to make sure people are building secure Shade agents.
Yeah, definitely. And I think I'm really excited to. An example I'm going to be building soon is actually using Fowler's GPUs, so we can actually enable some proper AI use cases inside of Shade agents, which were one of the reasons they were built. So instead of just interacting with a model itself, you'll be able to have like a verified model and then a verified agent that is doing something on top of that model and turning that AI part into actions, which will be really cool.
That'd be huge. Awesome, man. Is there anything else you want to flag before we move on to the final guest?
No, that's everything from us. Just check out the docs, and there'll be more coming soon.
Awesome. Well, Owen, hope to have you on soon, and we're gonna move on to Felix.
Thanks. See you.
Felix, welcome back.
Hi. Thanks a lot for inviting me again. Really appreciate to be
Absolutely.
here.
Yes, this is going a little bit longer than expected, so appreciate your flexibility. If you just don't mind, I know you've been on this show a few times, but for those who don't know you, who are you? What is Xtrace, and what have you shipped this week?
Yeah. Hi everyone. I'm Felix. I'm the CEO and founder of Xtrace, and then we are building the encrypted memory and context for AI agents. So today we'll show like a 40 end-to-end encrypted AI agent, also integrated with Fala, so that not only that you get protect from like all the prompt and query you have, but also all the data that is connected to. And it will also make sure that the agent, when you're talking with it, with the agent in TE, all of the data will be persistent memory, which means that it will recall everything about you based on what you're sharing with it. And still, you can own all the data because all the data is controlled by your secret key. So I'll show you first about like the architecture that I'm going to demo. So this will be the architecture that we're going to demo. Any app or like any, like for instance, Notion, Slack, or any of it that supports or SDK, which we support, the user will be able to encrypt and then upload all of their data into this encrypted vector database. And your Xtrace Cloud as a vector database holder, we can guarantee that we never see your data. And also when the agent is sending query to your database, we can also guarantee that we never see the query and the result, but still return the most relevant data to your agent network, which is really powerful. That can unlock a lot of use cases. For instance, like enterprise secure private keying, where they don't need to require anything to be deployed on-prem anymore. Now they can have like a fully remoted service, but still have the same privacy and security guarantee as on-prem service. And on top of that, we're also working on the encrypted memory. So the agent will actually remember interactions between you and the agent. And then all of this will be controlled by the user secret key. So only the user will be able to decrypt this memory and this data. Yeah, so now I'll quickly show you like how you can work with our system. We created a really developer-friendly user dashboard. So how it works is that the developer can create something like a near demo key. And then after having this, they'll be able to copy it, save it somewhere, and then connect to the agent key that the knowledge base that I want to work with. So now I can show that I want to connect with the near weekly demo, save it, and then the developer will be able to track all of the API key usage and also working on like the knowledge base that they have access to. And on top of that, we created a key that is called the admin key, where we can allow AI agent itself to create knowledge base based on their own understanding. So for instance, when we're chatting with agents, it can create a knowledge base about, oh, this is about like our personal chat, and it'll create like the private personal chat knowledge base and the work knowledge base and all that. So there's all kind of flexibility and control you can work with on this knowledge base. And it can not only be controlled by human, but also by the agent itself. So this is like a really basic proof of concept of how X-Trace can work with Fala. So this is also the API endpoint of like the large language model is also hosted on the Fala server, and then we're connecting to the X-Trace vector database. So now you can ask questions about like, for instance, who am I? And then it'll directly have access to like, to like all your private data and all your memory. So how it works in this demo is that I've already pre-uploaded all my ChatGPT memory and cloud memory into the system. So now when I'm starting a chat with the Fala agent, I directly have access to all my previous ideas. And then how it works here is kind of simple, but we can actually make all of this automated as well. So I can upload the data that I want. Let me try to find the place of I think the data is inside here. So we can have context, and then I can put like all the GPT memory here, and then you can see like the upload procedure is going. And then after it's uploaded, you can see like the data is reflected here. So you can see like previously this is 242, and then now after adding it becomes 248, which means I added 6 new vectors inside my system. And then now you can ask like questions about anything that is personal, private, or you can also work on connecting to like Slack channels, Notion, and all of that. So it'll have a persistent memory about you, and each user can control their own knowledge graph and then work with any agent that they want to work with. Yeah, so that is kind of like a demo and like a showcase of how to build out.
I mean, this answers a really big issue for me. I am so uncomfortable connecting my Claude or Anthropic account to my Slack, to my email, to everything. Like, I'm just not going to do it. But I really want the power of Claude to essentially, help me manage my life. And so I'm curious, like, how do you then plan to take this to sort of next step? Like, this exists today. How do you get distribution? Because I think currently a lot of people today are using these, traditional models, not traditional, but like, these larger AI company models. How do you plan to integrate with them?
Yeah, so in the last demo, like here as well, we created like a fully private MCP server that can control all your data from cloud and GPT. So essentially we'll become like this unified memory layer that can work with any agent that you want to, and we can make sure that whatever is stored inside our knowledge base, only the user have control over it. And then they can be the person to choose who they want to share with. For instance, they want for the more sensitive data, they can go to Fala and get like full confidential cloud, or they can have like some specialized small language model on their service, or it's for more like okay data, they can also still share it with different GPT or all of it. And then the point of like allowing, so we recreate like this unified memory layer. And then the reason why people would be willing to do it is because we guarantee we never have access to their data, because that's kind of like the moat for all these companies.
Got it. And this is so exciting. I guess besides Follow, like, how do you plan, I guess, the MCP server, but like, do people have to just specifically call your MCP server? How do you plan to like have people discover this?
Yeah. So currently we're still in a closed source stage, but we really plan to open source soon. So anyone who kind of filled out like this beta testing agreement on our request early access on our xtrace.ai website we'll give them access to like or SDK so they can kind of use it as like a vector database, and then they get like this access to this developer dashboard, and then now they can start building interesting agents on top of it. And then they can also, a cool thing about it is that if more and more people build upon our X-Trace SDK, then like all this agent will all support this common memory of the user. So it's no longer like isolated and siloed. And then like for developer, the good news is that once they support our SDK, they get access to the whole user data, and they can make sure what user wants to share and what they don't want. Yeah, so we're really looking into people trying to build on top of us, and it'll make it as easy as possible. Yeah.
That's amazing. Well, any hackathons that Proximity is running or Near Foundation, we should absolutely include you guys. I love what you're doing, especially on all the enterprise focus side. I am very skeptical of throwing all my personal information and treating these AIs as therapists and everything quite yet. But I want to, and so yes, I'll be checking out your MCP server as well.
Cool. Thank you so much.
Awesome, Felix. Well, thank you for joining. All right, everybody, we're about 15 minutes over our normal time, but it was probably because it was jam-packed with exciting products. And so today, again, is the 20th episode. Pretty happy with where the show is going. It's, I think, every episode just getting higher and higher quality. Thank you all for joining. Again, we do this every single Thursday. Next week, we already have a couple amazing projects lined up. So if you do want to if you are building in the Near AI ecosystem and want to present your work, feel free to DM me on Twitter. I'm Cameron_Dennis. I'm quite active, and so you'll see me there. Besides that, that's all we got. Hope you have a wonderful weekend, and hope to see you next week. Thank you.
Thanks for watching. Subscribe to Near Week.